Let us now focus our attention on how we take limits of piecewise functions. Here is a piecewise function. And as you can see, there are two functions we're familiar with, we should be. Here is our f of x equals x squared, or y equals x squared. But you also notice this graph over here, this is a constant function, y equals 3, or f of x equals 3. You also might notice that we don't have the graph all the time. We're only using this graph when x is less than or equal to 2. Now, I know it's less than 2, but how do I know it's equal to 2? Well, remember the solid circle? If the solid circle is part of the x squared graph, well, then it also equals that value. Notice over here, though, we have a different function. We're using y equals 3, or f of x equals 3, but not all the time. We only use it when our x value is strictly greater than 2. I know it's strictly greater than 2 and not equal to 2 because notice the open hole, the circle at the end of the graph. Graphically, that should make sense. We have functions, two different functions in two different parts or two different pieces of the graph, hence piecewise function. How do you write that? Well, if I have an f of x, there's my function, but the thing about it is it's not always the same thing. Sometimes my f of x equals x squared, and sometimes my function equals f of x equals 3. It's a constant. But when does it equal x squared? Well, it equals x squared when your x value is less than or equal to 2, and it equals 3 when your x value is greater than 2. And that right there is what you would see as a piecewise function. And whenever you're dealing with that, the breakpoint is what we're interested in. Okay, if you notice from the graph, well, here, let's just do this. The graph, we want to see what's happening at x equals 2, because that's the breakpoint. Are they going to meet or are they not going to meet? We want to see if the limit exists. The answer here would be the limit does not exist, simply because as you're coming in from the left-hand side, you're approaching y equals 4. And as you're coming in from the right-hand side, you're approaching y equals 3. They do not equal each other, therefore the limit does not exist. Let's spend a moment to look at this piecewise function that we deal with often, and you don't really realize it's a piecewise function. You see the absolute value of x, and all right, well, if I said graph y equals the absolute value of x, I'm sure most of you can give me that. It's a v, and the vertex is at 0, x equals 0. But if you think about this, this is y equals x, or f of x equals x, and this is y equals negative x, or f of x equals negative x. I switch it to make sure you're comfortable with both are interchangeable. Well, y equals x, well, yes, it is the y equals x line, and if you look at this right here, this is the y equals x line, or the f of x equals x line, right? But it's not the entire graph. It's only when x is greater than or equal to 0. Usually we put the dot with the positive side, which is not the case over here. Okay, so let's look at this. Let's put it in blue. So if you look at this graph, this is the graph y equals negative x, or f of x equals negative x, except it doesn't continue this way. It's not the whole graph. It's only, wait, that's not what I wanted to do. It's only this graph when x is less than 0. So, like I just mentioned, with a piecewise function, we are interested in that breakpoint, in this case where the vertex is, okay, at 0. So the question is, does the limit of our function is the absolute value of x, as x is approaching 0. I want to know if that exists. Well, if it exists, or for it to exist, we need to make sure that the limit, hey, let me write that down so you write it down. For this limit to exist, the limit as x is approaching 0 from the left side of our function must equal the limit as x is approaching 0 from the right side on our function. Let's see if that's true. Right. Well, when we are on the left side of 0, right? Notice over here, when we are on the left side of 0, we are using the function negative x. I'm going to put a question mark because we don't know if it equals yet. We're going to see if it equals. Does it equal the limit of our function as, well, here, let me do, as x is approaching 0 from the right? What's our function on that side? That's right, it's positive x. Well, let's now plug in and see what we got, because the rule with a limit is first step is plug it in, and if you can do that and get an answer, you're done. So if you plug in a 0 there and you get negative 0 equals positive 0, well, this is the one unique number where that's the same thing. 0 equals 0. The answer is yes, and it should make sense as we look at this graph, because as you are approaching x equal, here, let me change the color here to black, or let me make it bigger. Yeah. As we are approaching x equals 0 from this side, our y values keep getting closer and closer to 0. And as we do the same thing on this side, as we're approaching x equals 0 from the right, we are also approaching 0. Ta-da! Makes sense. All right, what about this one now? Let's see what they're asking us. There's another piecewise function, and the question is, pay attention what they're asking. You see that little plus sign? That changes things. For the function, determine the limit of f of x as x is approaching negative 4 from the right side. Oops, I'm still stuck on that. Hold on. Make that smaller. From the right side. Okay. Well, they're only asking us a one-sided limit. You've heard me say that before. If you didn't write it down yet, a one-sided limit. Okay, it's coming in from one side, in this case from the right side. So we have to determine, well, which one is the right side. When x is greater, right here, when x is greater than negative 4. Well, when x is greater than negative 4, well, think about that. Right, here's negative 4. When it's greater than negative 4, it's over here. All right, I'm going to say that that's the right. And just so it's been said, over here, when x is less than, or well, if it's less than, it's over here, okay? The right, that would be the left side. All right, so we don't want that. They're only asking us to use this function, okay? Because that's the function we use on the right, and this function we use on the left. So to find out the answer to our question, we are going to do what is the limit of x as it's approaching negative 4 from the right side of f of x, and, well, I'm going to just plug in what f of x we're using at that side. It's that f of x. Right? You don't need to put it in parentheses, but you can. Remember what I said. If you can take your number and plug it in and get an answer, that's all you do. So let's see what happens when we plug in from the right. There we get a negative 4 squared plus 10. Remember PEMDAS? I think that's what they still call it. Well, don't forget that we do exponents before we multiply that negative 1. So it's negative, it's exponents first. That's positive 16. That's negative 6. The answer is negative 6. Let's continue, though. Let's see if the limit exists at negative 4, not just from the one side. So let me get rid of this, and this right here, well, let's make that smaller and get rid of that. Okay. So, like we said on the other page, if we want to see if the limit exists, here, let's write this down. We want to see, does the limit of our f of x exist at x as x is approaching negative 4? That's our question. Well, for this to exist, we must see, does the limit of our function as x is approaching negative 4 from the left, does that equal the same thing? I'm going to put a question mark. We don't know yet. Does that equal the limit of our f of x as x is approaching negative 4 from the other side, the right side? Let's see. Which f of x do we use on the left of 4? Well, we have it written up there. The limit as x is approaching negative 4 from the left, we use negative x plus 2. And what f of x do we use as we're approaching negative 4 from the right side? We use negative x squared plus 10. We're going to take this negative 4 and we're going to plug it in, and we're going to take this negative 4 and we're going to plug it in because those are two polynomials and it's going to give me an answer. Well, this would be negative 4 plus 2. Does that equal negative 4 squared plus 10? All right, well, we did the right side up here. Okay, we know that the right side equals negative 6. Let's see if the left side equals negative 6. That's a positive 4. And yes, positive 4 plus 2, that's going to be a oh, I'm sorry, what am I saying? That's a positive 6. They do not equal each other, and so therefore the limit does not exist. Let us take a graphical look at this. And this should, let's compare the graph. So here, when x is greater than negative 4, we use this negative x squared. You might remember that negative x squareds are negative parabolas. That looks right. Ignore this point. This was just on a graph I took a picture of, but that is not what we're talking about. Over here, when x is less than or equal to negative 4, we're going to use this linear function. We're going to use negative x plus 2. So negative x plus 2. If you were to continue negative x plus 2, you're probably saying, oh, it probably has a y-intercept of 2. Well, you're right. It would continue. That is a line, but we don't use the line all the time. We only use the line, the linear function, when we're less than or equal to negative 4. Okay? And as you can see, we are approaching 6 from the left, yet we're approaching negative 6 from the right. The limit does not exist.